Hello, in this video we're going to do the Bowling Game Kata. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video we are going to implement the Bowling Game Kata, where you calculate the score of one game of 10-pin bowling. This video was requested by a number of people at my test-driven development workshop at this year's PHP UK conference. Let's look at the code. There are many different ways to implement the Bowling Game Kata. In this video, we're going to write a function that takes a string that represents a completed game of bowling and expect this function to return an integer for the score. One of the things you really need to consider when doing the Bowling Game Kata is which scores you're going to calculate first to ensure you don't have to implement the entire algorithm from the first test. You need to plan out your tests carefully so that you're not forced to write too much for each test. So let's make a start with our first test. The simplest test to start with will be a gutter ball game, when all 10 balls are thrown down the lane and not one pin is knocked down. We're going to represent not hitting a pin with a dash in this kata. So let's start our first test. We'll create a new test. We'll call it testing gutter ball game. So it's nice and explains what the test is going to do from just a function name. So gutter ball game. Okay. So we have new game. Game equals new. Bowling game. And score equals game. And we'll call the function calculate score. Calculate score. And it's going to take a string to represent a completed game. And as I said, we're going to use dashes to represent a ball that didn't hit any pins. So the format will be dash dash space, and we'll repeat that 10 times for our gutter ball game. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there we go. Okay, and now we need to do our assertion. So $assert equals. So we're expecting 0. We hit no pins for the score. There we go. Okay. So if we run that and see what happens, so we can run our tests. Okay. And our test is failing because we don't have the function, which is to be expected. So let's add that method. Let's do some renaming before we start. So this is game, returns an int. Okay. And make it increment, so let's return 1. Go, and if we run our test again, there we go. So we've now got an assertion failure. We expected 0, but we got 1. There's a really quick, simple fix for this. We can just return 0. And if we save and run that, our tests are passing. Brilliant. Okay, so now we need to move on to our second test. And we need to think carefully about how to slowly build up the functionality rather than forcing ourselves to implement everything straight off the bat. So what's quite common during the Bowling Game Kata, if you haven't done it before, is to think, oh, what's the next interesting one to do, and go for something like the perfect game where you get 13 strikes and the score of 300. But obviously that will work if you're doing string matching, but as soon as you start to actually have to implement a calculation algorithm, you then have to add quite a lot of complexity to that algorithm straight off because of handling that case. So what we're going to do now is we're going to do the next most simple thing. We're going to check for a single ball hitting a single pin. So we will do new test method, single first ball single pin game. Okay, so we'll do a little copy and paste. And this time, so we want the first ball is going to hit one pin, and that's it. That's the only change we're going to make to that. And we'll take our assertion line. Okay, and instead of 0, we now expect a score of 1. Now we can save that and run. Our test is failing because we expected 1, but we actually got 0. So how can we solve that? Now, as I said, we could start doing some kind of very simple string matching, but obviously we know that's not going to help us in the end. So we'll go straight into kind of starting on the algorithm. So what do we need to do first? Well, we need to look at let's look at a string. Let's remove these spaces. It won't make for those tests, but we'll start making. Each game is set up of 10 frames, and a frame can be 1 or 2 balls being thrown. At the moment, we're throwing 2 balls for each one here, and in the first frame of the game, we hit 1 pin. So we want to be able to inspect the string coming in terms of frames. So let's split the string based on spaces. So let's do, so let's call it frames equals string split. It's just split, I think. And check pattern and string. So we want to split on a space, and string is the game. There we go. So our frames should now be an array of 10 strings, each currently 2 characters long. So if we now loop over these, so I'm going to use a for loop. I equals 0. I is less than. I is less than 10. And I plus plus. Okay. So we can now loop over each of our frames individually, which is good. Okay. And what I'm going to also do is I'm going to start off this function with setting the score variable to be 0. And we'll just return the score here. Okay. So for our current game that we're trying to implement for, we know it's the first ball of a frame that we're interested in. So if we do something like this, so we can inspect, so we could do if dollar. Right, so let's start with some variables to make it clearer. So frame equals dollar frames. Dollar frames I. Okay, and now we can do something like this. So if is numeric dollar frame at position 1, so 0, the first part of that string. If it's numeric, we can do dollar score equals plus equals dollar frame position 0. So that's quite neat. That's reasonably neat and straightforward. So we're just looping over each of the frames, each of these frames here, like so, and we're just checking the first position of each frame to see if it's a numeric. And if it's numeric, we add the value of that to the score. So let's see if that works. It's not working. Yeah, forgot to put the dollar there. And that's why I say the word dollar a lot when I'm writing PHP. There we go. So our test is now passing. So that's nice and simple, and we're slowly stepping through adding functionality as we go. Not too much tidying available at the moment, so I don't think we're quite ready for a refactor yet. So let's go on to the next test. Although saying that, we're not ready for a refactor maybe on the left. We've done a lot of copying and pasting in that last test writing. So let's add a before, so we don't have to at least set up the game every time. That will be a first step. So private $game and new setup method. Oh, this needs to return void and dollar. Oh, let's just do this. Cut that out. And this game, new bowling game, and then this. Takes a line out of there. Okay. So there we go. That's nice and simple. A little bit tidier. Let's just check we've not broken any tests. We haven't. So now we'll move on to our next test. So new test method. So in our previous test we were looking at a single pin for the first ball. So let's now add a test for a single pin for the second ball of the game. So second ball, single pin game. There we go. Okay. If we take this again. So yeah, again the score should be 1, but we need to say second pin of that frame is where we hit the pin. And if we run it, we get an expected an assertion failure. We expected 1, but we actually got 0. So this is reasonably straightforward. We can then do another if. So if is numeric, frame at position 1. Then we want to, let's just copy paste, speed things up a bit. Okay, so save and run. There we go. Okay, so our test has now passed. So we are back to being in a good place. But we did obviously some copying and pasting there, so there's another chance potentially for a little refactor to tidy up. So we've got the same piece of code here as we have here. The only difference is the position we're looking at in the string. Here we're looking at the first position, here we're looking at the second position. So let's write a bit of tidy up code now. So let's have a look at it. Well, it seems like a good point to add a private function. So private function, now what should we call it? Get ball score. There we go. And it takes let's take an int, which is ball, and a frame. So it's a string, isn't it? String, frame. And we want this to return an integer. There we go. Okay, so if we take this logic here, copy and paste. So what we can do is so if the frame is, there we go. So we can use ball, $ball. Okay, and $ball. Now, if we pass in 0 and 1, that will work. But I'm thinking because we don't think about the 0 ball when we're playing a game of bowling. We think about the first ball or the second ball. Let's allow this to pass in 1 or 2 rather than 0 or 1. So we can do ball minus 1 and ball minus 1. Okay, so that's neater, and then we can just return the score. And if it doesn't find anything, it will return nothing, which will get changed into a 0. So if we take this code out now, we can do $score plus equals $this, get ball score for ball number 1 in the frame, $frame, and duplicate down, we can get the score for ball number 2. There we go. So that's made it a little bit tidier. Let's run it. Oh, I've broken it. What's my get ball score must return? None. So I do need to return a 0. Get to return 0. Okay. String returned. Int. Oh no. Still doesn't like it. What have I done? Oh, is it? Hang on. I'm just jumping the gun. Let's go back to where we were. Okay, so that returns that. Let's run the test and actually read the message. Here we go. Right. So the get ball score must return an int. A string is returned. Okay. So we need to cast this string to an int. So do int val. And that should give us the right value. So let's run it. There we go, green. Okay, should have slowed down and read the output a bit better. That was bad of me. Okay, so we're back to green, and our code is now back to being quite small and concise. We can see we're going through each frame. For each ball of the frame, we're getting the score and adding it to our final score and returning it. And our get ball score is a nice, simple piece of functionality. So with these 3 simple functions, we now know that we can calculate the score of a frame or a ball being thrown if the pins are missed or if we hit a pin. So we can now move on to looking at spare functionality, or what happens with spares. So we'll start with the simplest spare, which will be a 5, and to represent spares in the kata, what we're going to use is a /. So we will start a new test, new method, single spare. Okay. So what we want to do is jump in here, and we're going to grab the test above. Okay. And now what we want to do is we want to look at this. So 5 and slash. So that means we hit 5 in the first ball of the first frame, and then we knocked down the remaining 5, which is represented by this slash here. So if the 5 was a 4, then the slash would represent a 6. So the score for a spare and nothing else happening is 10. So if we save that and run the game, so we're getting a failure because we expected 10, but we got 5 because we are only looking at these numerics. Okay. So let's look at how we can do this. What we can do is so what we could do is you could do something like this. So we know that the spare is the second ball, so we could look for a slash in the second space. So if $frame Position 1 equals a forward slash. So if we get a forward slash, let's use triple, be extra good. There we go. If we get a forward slash, then the dollar score plus equals 10, and then we can do else and take that out and whack it. Oh no, not there. Here. So if the frame is a spare, then we just straight away add 10 because we know it's 10, and we else we continue to just calculate the score based on the balls thrown. That should be enough. So if we run that, okay, we are back to green. Now, the next thing about scoring a spare is if you score a spare in bowling, you get 10 for the that first frame. But if you hit any more pins in the first ball of the second frame, then that score gets doubled. So we need to add a quick test for that. So we add new test, spare. Well, hang on, because, well, no, let's carry on with this. So spare and a 5, and 5 pins. Next game. Okay. So let's just roll that over, and then we change this to a 5. So the score for this game should be 10 for the first frame, plus 5, and then plus 5 again, because we're doubling it for the spare in the previous frame, meaning this game should equal 20. So if we save that and we run our tests, we're getting a failure because we are not doubling the we're not doubling the 5 for the second thing. So we need to do that. So how can we do this? So we can, well, hang on. So we need the previous frame now. So let's have a little think. So the previous frame is, so think it through. Well, so previous frame equals dollar frame at I. Well, we could look at the previous frame, or we could just look at the next frame and double. Now let's look back. I think that's going to be more sensible. So -1. So, okay, so we've got the previous frame, but we can only get the previous frame. So if dollar $I is greater than 0, okay. So no, do we want to look at the previous? Yes. So how can we do this? Oh, I know a nice way. How about this? Okay. So ball 1 multiplier equals 1. Okay, and if that, so we've got the previous frame now. So, and then if the previous frame is a spare, this is a bit messy. I think we need to tidy up. So, if the previous frame is a spare, ball1 multiplier equals 2. There we go. So if the previous frame is a spare, and then if we times $ball1 multiplier. Okay. So I think that should fix it. Let's have a look. Oh no. Hang on. Right. So we're getting ball1 multiplier should do it. Position 1 equals a spare. Ball1 multiplier equals 2. Okay. So if oh yeah, there's my typo. Let's try that again. There we go. Now we fixed it. Okay. So let's have a look. So that's made the functionality work, but it's a bit messy. So let's look at, we've got some duplication here. So we've got previous frame equals slash and this. So, but it's not really explaining what's going on. So let's look at maybe improving this. So let's do, let's move this out to a new function. So if we put it out to a method, so is spare private takes a frame. There we go. So we've moved that out. Let's have a look at where that went. Okay, right, we don't need this, so get rid of that. So frame position 1 equals slash, it knows it's a frame. So then what we can do is we can ask if the, so $this is spare, and we can pass in the previous frame. There we go. So that's a bit neater. Okay. So that's a little neater, and we'll just run that to make sure that's still green, and it's still green. Okay. And if spare at 10, right, okay. So, and that concludes the testing of spares now. So now we can move on to testing the strike functionality. So if we do a new test, and we say, so we're going to strike first ball strike. Oh, strike, spell it right, there we go. Okay, so we now take, let's take this simple game here, copy. Okay, now strike is when you hit all 10 balls in the, all 10 balls down with your first ball, and it's represented with uppercase X. So there is no second character for this frame because you only have one ball when you score a strike. So the score should be 10 at this point, and that's it done. So let's roll the test and see where we're at. Okay, undefined offset 1. So this is where it's starting to become more interesting. So let's, so we're breaking things now so what we could do is, well, where's it? The undefined offset. Let's look at that first. So bowling game 45. So it's spare. Okay, so before we ask if it's a spare, what we can do is we can say dollar. So well, let's take the frame at position 0 equals x, or or there we go. So if it's a spare, if it's a strike, sorry, or is a spare, then we just add 10. That should probably give us no, not a passing test. So undefined offset 1, 45 called from here. Okay, well, we can move this functionality because this only counts on the non. There we go. Save. I think that should. No, still not passing. 46 spare. Call it 23. Oh, hang on. Let's make this a little bit. So return. Str. The string length is equals 2, and there we go. That's better now. Okay. No. Oh, we got 5. That's fun, isn't it? Where did we get 5? Not expected 10. Expected 10. Got 5. Oh, have we broken a previous test now? Hang on. Oh dear. Right. Let's undo our changes. So this is where test revert commit, test commit revert even comes in a little handy. Forces you to make those tiny changes. Okay, previous frame. Okay, and then let's run this. Okay, which test is failing? Undefined offset. It's our strike game. So let's go and fix that. So now we know. So if string length string length of the frame equals 2, and the second position is a slash, it's a strike. Right, let's run that. See if we. There we go. There we go. That's better. Just I think I was a bit doing too much there. Okay, nice and simple, nice and clean. Okay. So there we go. Now then. Okay. So first ball strike. Okay, now we need to move on to the next part of the strike scoring functionality. So what happens when you score a strike is the next 2 balls you throw are doubled. So let's do that. So this is where it becomes more fun. So if we take this, copy, paste, and so we do 2 and 2. So the score should be 10 and 2 and 2 is 12, but we're no, sorry, 14. But we're going to double those, so that will be 18. Okay. Okay. So if we 18, yep, we run that. So it's actually 14. So we haven't yet doubled there. Okay. So then, now we need to multiply ball 1 and ball 2. So if we ball 2 multiplier, like so, and copy, paste, ball 2 multiplier. So we need to do that. So that should leave us in the same place as we were. Yep, brilliant. And let's down a bit. Okay. So let's go into here, and we're going to do an if frame. We can do an else if, couldn't we? Else. Let's bring this up here like that. Make it a bit neater. Else if that, and then ball duplicate and ball 2 multiplier. Okay, save. So if we run that, we've got 14 still. Have I missed something? Ah, yes, did. We want to look at previous frame. So there we go. There we go, and we're green. Okay. So we're back to green, and we, at this point during spare functionality, we made a bit of a refactor, and I think now's a good time to refactor this part out. So if we turn that into a function, we call it is strike. There we go. And we just run it to make sure we're still green. We are, and then we can do this is strike, and we give the previous frame again. And if we run that, yep, green, and then just another refactor for the typo, previous frame. There we go, much nicer. And run it, and we're still green. Okay, so that's working, which is good. Okay, now then, so we've got that. So the next piece of, oh, I didn't name this function. Let's fix that now. So first ball strike, next 2 balls, 2 pins. There we go. Okay, save. So now, just as thinking about the function naming, there's a chance this doesn't really explain the functionality. So instead of we say 2 pins, what we could say is next 2 balls doubled. So actually explain the functionality, the kind of the logic we're testing here. So let's do that, and spare, and so we can say next ball doubled. Yeah, so that's cleaner and clearer. There we go. Okay, so now there's an interesting part, because you need to resolve the if you score a strike on your first ball of the final frame, you need to resolve that strike. So here comes some fun stuff. So public function test all strikes. Hang on, let's do this. Final frame strike resolved. Okay, there we go. So let's take this one and let's take the same functionality but put it at the end. So we need to replace. So we need to take these. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and then we need to add 9th, and then we do this. So strike and 2 and 2. So in the final frame of a game of bowling, if you get a strike, you get 2 more bowls to resolve it. And the same happens for spare. So, in fact, let's start with the spare functionality. So final frame spare resolved. There we go. Okay, so now it's 5 and slash and 2. Okay, so that would be 14. Save. Okay, so if we run this, we have a look, we get 5. Actually got 5. Oh, that's interesting. It shouldn't be 5. Ah, of course. So, I know why it is 5. So the reason it is 5 is because of our is spare takes a string length where it must be 2. But as we can see here, it can be greater than 1. It can also be 3. So we'll play, and where are we at? So we've got 10, we expect 14 because we're not doubling the not doubling this one because we don't even know it exists yet. We're not doubling that too. So let's have a think. So tidy up as well. Get that. Think about it. Save. Didn't break anything. Okay. So let's look at our logic. I'm starting to think this, looking at the previous frame, was potentially a bad idea at this point. Because by looking backwards, it means for this one case, we then need to look forwards to the next ball, which is not potentially not the best way to do this. Because if we had a way of just looking forwards, so let's have a think. So we've got the frame. Ball one multiply. How are we going forwards instead? So if we look forwards, we can take the next ball and just add it. How would it look? It would simplify this down as well, thinking about it, get rid of this multiplier stuff. So let's think, if it's a spare, then we want to get the next ball. Then we'd also get rid of this there. Let's do this. Okay, let's just do this for spare for now. Instead of ball multiplier, what we can do is we can do $score plus equals if, hang on, no, we'll delete it. Let's so I'm fumbling about in this. Let's close off that one and do else if, and bring the spare functionality down. Next, paste. There we go. Yep, that needs to be there. So if it's a strike there or a spare, we do that. Okay, bit of duplication, but not too bad. Okay, but if it's a spare, if, oh, here we go. So if $I equals 9 for on our last thing, what we do is we do $score plus equals dollar frame, and then we want well, so we can use this functionality now, can't we? So for ball number 3. So if we're in the last thing, there we go. Okay. Else, if it's we then want the next frame. So the next frame is dollar frames equals dollar frames $I plus 1, and we want to add the score of ball number 1. Save. Oh, that's a bad alignment. And we want to give next frame. There we go. Okay. So if it's a strike, and we're on the last frame, add the score for the 3rd position. There we go. So I think we can now take out this there. Let's see if I've totally broken that. Oh, I've broken something. Oh, here we go. Which line is this on? 73. Okay, so we've just, okay, we're missing something. So score plus equals 10. If I equals 9, score plus equals frame. Look at it. That should be right. What am I missing? Missing something. Ah, silly me. Times 2. Is that right? It should be counted for double. So the only thing here is I need to check it. So I'm going to go into Chrome. I cannot remember how the screen works here. So I use Bowling Genius. Bowling Genius. Here we go. Okay, so wait for it to load. Here we go. So 0, 0, 0, 0, loads of zeros. Okay, and our game is set up to be 5, 5, 2. So 5, 5, and 2. It should be 12. You don't double. That was, yeah. Because you're only resolving, so it's only equal to 12 because it's not actually part of your score. Oh, silly me. There we go. So we don't need this times 2. That's me being rubbish. I'm not testing my theory. So let's play it now. And we're green. Okay. There we go. Nice and neat. Okay. So, whilst we're here, this is probably also a nice time to refactor this into working in the strike, sorry, to be working in the same way as the spare. So let's just do that, but we're only going to give it the understanding of a strike in the game and not in the last frame. So we can do that as we please. So if it's strike, their score equals 10 plus, and then we take next frame, copy, paste, and we want ball 1, duplicate, and ball 2. Save. So now we should be able to take out all of this. So save that and run it. Yep, excellent. So that's still green. So we can now take out this multiplier stuff. So there we go. Save that. And we remove this. And we remove this. Okay. There we go. So save. Right. So we're reasonably neat. And let's green edge on that. Yes, we did. Okay. So now we need to resolve the final strike functionality. So if we do that, new test method, final frame strike resolved. So there's that. Okay. So if we copy that. So it is going to be like this. So let's take out the spare and we'll say we do X. So strike and then 5 and a 2 for the next 2 balls. Okay, to resolve that. So if we roll that, surprise, surprise, undefined offset. So this is because we haven't started to implement this functionality. We haven't got this kind of if I equals 9 and stuff. So it doesn't understand here that the frame needs to be handled slightly differently. So let's start doing that. So, well, let's take that. We know that this here works. So copy that. So if it's there and there, save. Okay. So if it's the last frame, we need to take the score for ball 3. Well, so this is where it becomes different because for a strike, it's actually balls 2 and 3. So we take the score for ball 2 and 3. Okay. Okay. And now we play. Oh, and it's 17. Oh, that's my bad. Completely stupid. So yes, it's 10 and 5 and 2, which is 17. I forgot to change that. There we go. Bit of keen there. So run that, and it's green. Okay, cool. So that's looking really, really nice. Really straightforward. Okay, now that becomes quite interesting because I think there's functionality that's still missing in resolving the spare and resolving the strike. So how about if something like this happens? So new test, and let's do final frame. What's the answer? So final frame, spare, then strike, resolved. Resolved. There we are. Okay, so what do I mean by that? Well, let's take this for test. So if you get 5 and then 5, and then you ace it and get 10, the answer here should be 20, because you're getting 10 for the spare and you're resolving it with next ball and getting a strike. So save that. Okay, so now if we run it, yeah, it doesn't pass. So we expected 20, which is correct, but we only got 10. And that is because when we get the ball score for position number 3, hang on, where are we? This is in the spare. Ball score for position number 3, it's returning 0 because it doesn't know that the ball score should be 10, which is a bit naughty. So we need to do something like else if oh no, don't want the whole thing, do we? Just want the copy. So if the ball at that position equals x return 10. Okay. So hopefully that now fixes our problem. Beautiful, it does. Okay. Right, well, that's looking nice and neat still. So we run it, and yep, we're green. Okay. So now we need to start looking at the kind of opposite of that. What happens if you get a strike and then a spare? Is that right? Yes, the other way around. So if we create a new test, final frame, strike, yep, then spare, resolve. Okay, so we'll take this again. Again, the score should be 20 because we're just scoring 2 10s. So it's now, take that and pass it like this. So we've got a strike on the first ball, we're resolving it with 2 more balls, and we score 5 and 5 again. If we run this, okay, so we're expecting 20, but we're getting 15. And again, we're getting 15 because it's this slash is not being resolved. Okay, so let's go and look at how we can look at this. Well, so now we're getting quite tricky because if we pass in a slash, oh no, we pass in the whole frame. So we could do this. This is quite interesting. Okay, so because we pass in the whole frame, if the position, if it's a slash, we can still calculate backwards. So let's do that. So how about this? Else if the so if it is a slash, then we can return this. So we want the, so it becomes fun. So it is return 10 minus the, let's copy this, and it's always going to be position 0. Okay. Is that enough to fix it? 10 minus the, I think it might be. No, it's not. So non-numeric. No. Yes. It's actually going to always be, this is better, because it wouldn't be 0 here, because 0 is the x. It would be ball minus 2. So it's the, there we go. Okay. Does that make sense? So for this one, we'll use this case. So we're here. Okay, so we've calculated 10. We have added 5 to it, and then we've got to here, and we know that it's a spare, so it needs to be it needs to be 10. We know we've got 10 minus the previous ball. So if we save that, I think that's going to run it. Oh, it does. Yeah, that's really cool. So that's quite reasonably neat there, like that, isn't it? Okay, so that's looking pretty good. Okay, so we're now nice and clean. We've done quite a lot of refactoring. We've got some nice stuff working. There's some more refactoring we can do. We can take this. This is easier to understand if we say move it into a method and call it is last frame. Refactor, and yes, we want to replace both. So if is last frame and is last frame. Where's it gone? Oh, I didn't do both. Okay, well, we'll just copy and paste that anyway. And paste. There we go. Okay. That's reasonably neat. Right, now let's think through some additional tests. Now, I think I'm going to add some tests and they're going to straight away pass, but let's try them out because they're, well, so there's one case I want to test for. So new case, final frame 3 strikes resolved. Okay, so let's just take this one. Okay, so obviously previously you have to resolve the what do you have to do? You need to resolve the next 2 balls. So for a strike, so it's this, and then there needs to be 2 more balls. If you score, well, let's just draw out. So if you bowl 1, you've got 2 more balls left. So if you bowl another ball and knock all the pins down, you get a strike. And you get 1 more time, and you get another strike. Okay, so the score for that is 30. Okay, so let's run it and see what we get. And that works perfectly fine. Okay, that's really cool. So the other thing I want to check is also what we haven't played with is what happens if you get strikes and spares in the middle of the game. So let's do that. So first 3 balls, all strikes. So it's going to equal 30 again, so we'll take this. Okay, but in the last one, you get gutter balls, so it's just dash dash. But for the first 3 balls, you get X, and you get X, and you get X. So save. So now we play again. Okay. So we've got undefined offset. Let's go and look at what's happening. So we've got the bowling game here. So it's on 45, we're getting the issue. And it's when we try to get the ball score, and that's happening on 25. Okay. So this is where it becomes kind of slightly more interesting, because we're looking at the second ball happening to be in the 3rd frame, not in the 2nd frame. So we need to look at how we're going to fix this. So how do we do that then? So we are looping through what we could do. So it's in here, isn't it? Yep, it's here. So we could do another if. If is strike, copy. So if the next frame is a strike, it's getting very ugly again. Feels like there's probably going to be a chance for a refactor. Okay, so if the next frame is a strike, so if we do else, we want the previous functionality to come down. Then we want the hideous naming, but next frame to be, so we need I plus 1, and we want the score of the first ball of the next frame. This is really getting quite complicated. Right, let's save that and run it. No, still broken. We got, oh, hang on, actually got 60. Wowza. Why do we get 60? So you get 10. Oh, hang on, I might have mucked this up. Hang on, let's think this through. So, well, let's do it the easy way. Switch to this, bin this game. Okay, add another game. So it's 10. So 10, 10 here, and 10 here. That's 30. Oh, yeah, it's 30. So it's, oh, what have I got here? Oh, hang on, no, because I need to add the zeros. This is where it gets interesting. So this is 30 here. Then I add the 0. Oh, no. 10. There we go. No. Add another game. Right. So 10 and 10 and 10. And then the rest of the games are gutter balls. Oh. Forgot about the doubling. Oh, whoops. Yeah. Right. Oh. Go away. Close. It was 60. So that was my bad again. It should have been. So if you think about it, it's 10, add 10, add 10 for 30. And then this is a 10 again for 40. and this is a 10 again for 50. And then this one comes around again for its own score of 10, making the game 60. Far too far ahead of myself again. There we go. Okay, so my code was correct for that. Okay, well, that's good. Now, let's see if we've got another test to do. Let's try something like spare then strike. First 3 balls. Strike, sorry. Strike. Then spare. Does this work? So let's copy that. So this one becomes gutter board again, and we do 5 and 5. Okay, right. I'm just going to trust the bowling game. Close. Bin it. Okay, add another game. So what was I set up? 10, 5, 5. So 10, 5, 5. And if we add some zeros. Right, so this time it should be 30. There we go. 30. Okay. So let's run it. Cool. And that game passes as well. Okay. Well, I kind of think we're almost there. I think. Let's try the perfect game. Let's add the perfect game, shall we? So, new test method, perfect game. So, let's take the thing. Now, one thing I do know, well, no, I'm going to double check it because test everything first. Perfect game, add another game, 10, 2, yeah, perfect game, 300. So, score should be 300. It should look like this. So, X, 3. Sorry, it's probably a bit tedious at home. And the final one, XX. And one more. There we go to resolve it. Okay. We run it. Ooh. Undefined offset 10 on 26. So what's happened here is because I've been thinking about frames and then balls, I've kind of programmed myself into a corner, and this is something on the bowling game you have to be quite careful with. So I'm at a point where in my test here, okay, the strikes in here work and the strikes in here work, but when you get to this strike here and it's looking for its second ball to resolve, because it's found a strike, it's now expecting to find a strike in the next frame, but there's not a next frame. So this is where it becomes interesting. So there's a way to fix this reasonably straightforward, and it is to take where's our strike functionality? So if it's a strike, if it's the last frame, and we have to do this kind of, so we take this else down and we put another else if in. So if else if $i equals 8. So we're looking now at the penultimate frame. Okay, so that makes that work. Let's bring that down to a new line. Ooh, it's not liking stuff. Oh, it's because I've got else if. There we go, bad of me. Right, so if we're on the penultimate frame, then we can where are we? So we take the just take the next frame, like so, and we get the score of the ball at position 1, and we get the score at the ball of position 2. Save. I think that fixes the problem. It does. Okay, but our code is getting very big now and really quite ugly. But that does work. Okay. So our perfect game works. So now we're on to testing new test method. Let's just make up a random game. Let's call it a normal-ish game. Normal-ish game. You know, the sort of thing that your average person would do. So let's say, right, let's start with a blank slate. It's probably a bit easier. Let's take this one. Right down the bottom. There we go. Our normal-ish game. You know, you hit 1 and 5, 6, and then you know, let's do kind of 3 and 3 for 12, and well, you gutter ball it, and then you get a spare because that usually happens in a normal game, and then you score 5 and 4. What's another common thing to happen? Split pins, so that would be 8. So like that, and then you fluke a strike in the game, and overconfident, you hit a 2 and a 2, and then you, what happens? I don't know, 9 and a 1, and then, oh no, yeah, 9 and a 1, 8 and a empty, and then you finish on a 9 and a gutter ball. There we go. Right, so let's rely on our testing. So that went off screen. There we are. So that's a bit more readable. So let's kill that game off. Okay, and let's get this to calculate our score, because otherwise we'll be here forever. 1 and 5 and 3 and 3 and 0 and 10 and 5 and 4 and 8 and 0 and 10 and 2 and 2 and 9 and 1 and 8 and 0 and 9 and 0, giving you a score of 97. That's a reasonable score, isn't it? 97. There we go. Okay, so if we run that, cool. So our bowling game is complete. I think we've got all of the functionality now covered. It all works. Our code might not be the best, but we have an implementation that works. As I said at the beginning, there's different ways of implementing the Bowling Game Kata, different kind of ways of doing the rule set. You can do this calculate score where you pass the string, or you can have a way of doing it where the function takes ball. So for each ball, you give it a score until you've bowled your up to 22 bowls, and things like that. As there are different ways of kind of different rule sets of how the implementation should look from the outside of the bowling game, there are also different ways for the implementation to go. So for this one, I made a choice to stick with the frames and keep that frame idea into my implementation. There is also a second way to work this kata, where instead of just thinking about the frames, you just think about the balls. So you don't consider frames at all, you just work at a ball level and do your calculations based on that. And what I think I'll do is I think I will redo the kata, and instead of thinking about frames and balls in the next implementation, what I'll do is I'll just do balls and show you how that implementation works, and maybe show you kind of difference between the implementation and different handling and the different way the code comes out. But for this video, that's it. That's the completed Bowling Game Kata. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Bradle.